So in this video, we're going to go over graphing radical functions. So we really want to know what is the visual representation of a radical function. So also we're going to answer the question, what is the domain, range, and transformations of radical functions? So first of all, we're going to remember that we solve equations in the form x squared equals k by taking the square root. So that's this blank of each side, and the equations of the form x cubed equals k by taking the cube root of each side. Square root functions are the inverse of quadratic functions, and cube root functions are the inverse of cubic functions. I'm going to show you that on a graph in just a second. So in example 1, we're going to compare these graphs of f of x equals x squared and f of x equals the square root of x. So to do that, we're going to go ahead and graph these. So we're going to make a table of x and y values so we can figure out what this graph looks like. So I want to talk to y'all about if I square a number, if I square a negative number, it becomes positive, right? So what is the largest negative number I can square that will fit on this graph? Some of y'all know it's -3, right? Because -3 squared is 9, right? So we're going to then move to the right here. Actually, let's do 1, 0, 1, 2, and 3, okay? So we're going to do all these numbers just so we can get an accurate graph. So -2 squared, -2 times -2 is 4, -1 times -1 is 1, 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, and 3 times 3 is 9. So we're going to go ahead and now plot these. So we've got -3, 9 right here. Oops, didn't hit that one right, did I? -3, 9 right there. I guess I need to calibrate my thing. So then we've got -2, 4 right there. And then we got -1, 1 right there. And then we got 0, 0. Then we've got 1. Sorry, I definitely need to calibrate this. There, and then we've got 2, 4 there, and then we've got 3, 9 up here. So then we're going to actually draw this graph, okay? So I'm going to see if I can, how good a job I can do with this. It's not going to be perfect, but it'll be close enough for our purposes. So there is the graph of y is equal to x squared. So now I want to talk to you about domain and range. So domain are x's, right? Those are the x values, and range is our y values, right? So when we're looking at our domain, do you see any restrictions when we're moving from left to right here? I would say no, there's nothing limiting this graph from left to right. So our x values are going to be all real numbers, right? So I'm going to write all real numbers here for our domain. And that's the symbol for all real numbers. And then, but when we look at our range, then we're talking about our y values, right, guys? We're talking about these values. So do you see any limiting factors on the y values? Hopefully you would say yes. So our y's are all greater than or equal to 0. Hopefully you guys see that, right? Okay, so now we're going to talk about the inverse of x squared. Okay, so we're going to do in one color the square root, the positive square root of x. So we're going to do that here. And then we're also going to do in a different color the negative square root of x, because normally we would take plus or minus, right? And this is just for the purpose of you guys being able to see that these are inverse graphs of each other, okay? So on this one, again, so what I'm going to do is I'm going to put these values of y in for my x. So I'm going to put 9 and 4 and 1 and 0, okay? Those are the values I'm going to put in because those are the positive values that I got here. So when I take the square root of 9, I get 3. When I take the square root of 4, I get 2. When I take the square root of 1, I get 1. When I take the square root of 0, I get 0. So I'm going to put numbers in there that I can actually get square roots of. So with the x, when x is 9, y is going to be 3. When x is 4, y is going to be 2. When x is 1, y is going to be 1, and when x is 0, it's going to be 0. So this is the graph of the positive square root of x, okay? Now we're going to talk about the negative square root of x, okay? And again, I'm only doing this for the purpose, because normally we would only graph the green guys, but I'm going to show you guys this just so you can see. So this time we're going to use the same numbers, and I'm going to put them in reverse order, 0, 1, 4, and 9, which we could have done the other one that way as well. Now remember, we're going to change these to negatives, all of them. So this is going to be 0, -1, -2, and -3, right? So here again, we've got 0 there, we've got 1, 1, we've got 4, -2, and then we've got 9, -3. So this is the negative square root of x. So if you look at the graph of f of x equals x squared over here, this one, and then you compare it to the graph over here, you should notice that it turns, and it turns on the line x is equal to y. And that's because we flipped the x's and the y's, and you should very quickly be able to see that we did that, okay? So now when we're talking about the domain and range here, we're talking about all real numbers. No, sorry. What am I saying? So let's look at the domain. So now again, we're only concerned with the green graph, okay? So we're going to talk about the domain and range of this one right here, because that's the positive square root of x. So the domain is x is what? Greater than or equal to 0, because our x values are going that way. Hopefully you see that. And our range is the same thing. Y is going to be greater than or equal to 0, because it's also getting bigger, okay? So now we're going to compare the f of x equals x cubed to f of x equals the cube root of x, okay? So this time I'm going to use numbers. I'm just going to move from negative to positive. So again, we're going to use a table over here. So we got x and y. So I'm just going to do -2, because I know -2 times -2 is 4, times another -2 is -8. So that's going to be -8, and then -1 would be -1, and then 0 would be 0, 1 would be 1, and 2 would be 8. Now I'm doing these numbers because I don't have a number bigger. So if I do -3, that's going to be -27, and I don't have -27 on this graph. So we're going to go ahead and plot those. So we've got -2, -8 down here, right there. And then we've got -1, -1 there, 0, 1, 1 there, and then 2, 8 up here. So here again, we're going to graph this up over, sorry y'all, like that. So that is the graph of f of x equals x cubed. So now when we talk about the domain and the range here, I don't see any restrictions on the domain and range. So we're going to say all real numbers for both our x values, which are left and right, and our right values, which are up and down. So now when we talk about the cube root, remember, when we're talking about inverse graphs, these are inverse graphs of each other. So we can put in the values for y in for our x now. So that's what we're going to do with this graph. We're now going to put our y values in for our x's. So we're going to do our -8, our -1, our 0, our 1, and our 8. And the reason I'm doing that is because I know those are perfect cubes. So when I do that, the cube root of -8 is going to be -2. The cube root of -1 is going to be -1. 0 is going to be 0. 1 is going to be 1, and this is going to be +2. So when we do this, we got -8, -2 there. And then we've got -1, -1, 0, 1, 1, and then we've got 8, 2. So this is our graph of the square root of, the cube root of x. And here again, we have no restrictions on domain nor range, because there's no starting or point with respect to these graphs, okay? So these are the graphs. And now the reason why these graphs are important is because as we work through these problems, what we're going to change are these graphs. So we're going to start transforming these graphs as we move through this lesson. Okay, so I want you guys to recall here that graphs of radical functions can be transformed using the methods similar to those used to transform quadratic functions. And when you guys learned about quadratic functions, you learned what a did, what h did, and what k did here. So we're going to talk about what these are. So first of all, a has to do with a vertical. So a is a vertical stretch or shrink, okay? So it's a stretch when a is greater than 1, and it's a shrink or compression. We'll call it a compression. A vertical compression when a is less than 1, okay? So that means when it's a vertical stretch when a is bigger than 1, but here this has to do with it being fraction or decimal, okay? That's when we know it's going to be a compression, okay? Now our h, for me, I always remember this because h is horizontal, okay? So this one is a horizontal movement. So h is horizontal translation. And here's the rub, because there's a minus up here. Y'all see that minus right there? When it's positive, we're moving left, because that would mean there'd be a negative number in there, because a negative times a negative is positive, okay? So when it's positive, we're moving left. And when it's negative, we're moving right, okay? So when it's positive, we're moving left, and when it's negative, we're moving right. So could you guess what k is? So hopefully you have guessed. So this k has to do with a vertical translation. So on this one, because it is plus, when it's positive, we're going to move up, and when it's negative, we're going to move down. So now we're going to talk about a few extra rules, but we're also going to talk about the ones we just referred to now. When we're talking about a cube root or a square root, these rules apply. So first of all, we have a negative a. So in other words, if this value out here was negative, y'all, then that would be a reflection over the x-axis. And if this was negative under here, in other words, underneath the radical, then this would be a reflection over the y-axis. Now, we already talked about a, if you recall. We said a out here, this a, is a vertical stretch when a is greater than 1, and it's a compression when a is less than 1, okay? Now the b, this is a little bit different because it's 1 over b. So we're always going to talk about inverses here. So when we talk about b here, so this is our b right here. So when we talk about that b, we're going to be talking about a horizontal. Now this one's different. So it's going to be a horizontal stretch when b is less than 1, okay? And it's going to be a horizontal compression when b is greater than 1, okay? It's different because it's 1 over b, so it's going to be the inverse, okay? And then again, remember that h is horizontal translation. So this one has to do with when h, okay, well, let's just say when it's positive. How about that? When it's positive, then it's going to move left. And when it's negative, it's going to, sorry, when it's negative, it's going to move right. And again, that's because there is a minus right there, okay? And then with k, these are going to be vertical translations. Again, when it's positive, we're going to move up, And when it's negative, we're going to move down. Sorry, I keep doing that, -1. I don't know why. My brain is just automatically does it. So this one's going to be down. Okay, now we got a couple more things to cover domain and range, okay? So we're going to practice these first, and then we're going to cover domain and range, okay? So, the first thing is if we have a negative out in front of the radical, then like we do here in this example, the first example here, then this is going to be a reflection over the x-axis, okay? Hopefully y'all remember this. So this is going to be a reflection over x-axis. And then if we have a negative underneath the radical, it's going to be a reflection over the y-axis. Then we're talking about A again. So out front of the radical, this is going to be a vertical stretch. This one is, because it's greater than 1. So this is a vertical stretch by 6. The next one is going to be a vertical compression by 1/2. Now remember, this next one is opposite of what we would think. So when it's underneath the radical, it's 1/b. So we're going to do the inverse of what's there, okay? So so on this one, next one's going to be a horizontal. And this one, because it's a fraction, is going to be a horizontal stretch. TCH, if I could spell it, would be great. STRE. And this time it's going to be a horizontal stretch by, and we're just going to take the b, so that's going to be 5, okay? And then the next one, we're going to put 1/b, okay? So this one's going to be, because we're going to do the inverse always, so this one's going to be a horizontal compression, and this one's going to be 1/5, okay? Because it's always going to be opposite of what's there, the inverse of what's there, okay? So then we're going to talk about h and k. So in this first one, sorry, it's +3, so this one's going to be up 3, right? The next one's going to be down 4. And then k has to do with horizontal change. So this is left and right. So remember, this one's going to be opposite because in the equation it's a minus. It's x minus h, right? So if it's a negative, then it's going to be right 2. And if it's a positive, it's going to be left because it's really a negative by 1, okay? So, okay? All right, now we're going to talk about domain and range. So we're going to be talking about domain and range of f of x equals the square root of x, okay? That's what these are. Because remember, the domain and range of the cube root is going to be all real numbers, okay? So if the graph goes up and to the left, what's happening to the domain? So here, we know that the numbers for x's, remember, x's are left, right, so this is this way, right? So what's happening? So this is x is going to be less than or equal to, and this is going to have to do with our h values, okay? So whatever our h is, it's going to be x is less than or equal to h. And in this case, our y values are going to have to do with our k, right? So again, when we're talking about our range, we're talking about up and down, right? So what's happening with this one? This one's getting what? Greater than or equal to what? Our k value, okay? So remember, our h and k are going to affect our domain and range when we're talking about square root functions. So over here on the next one, this time what's happening to our x values? Looks to me like they're still going to the left. So again, our x is going to be less than or equal to h. And what's happening to our y values? This time they're going down. So this one's going to be less than or equal to k. So again, remember that the direction of the graph is going to tell you the direction of your arrows. Okay, that's the easiest way to remember it. So on our next one, it's up and to the right. So again, what's happening to our x values? This time it looks like they're getting greater than or equal to our h. and our y values are also getting bigger, right? So this is going to be greater than or equal to k. And our last graph over here on the right, what's happening to our x values? They're getting greater than or equal to h. And our y values are going to be less than this time or equal to our k. So when you guys are talking about domain and range, you're going to look at your h and k values to determine what they are. All right, so for example 3, we're going to describe graph, find the domain and range of the transformations. The first thing I want to do is describe the transformation. So what does this 2 right here represent? So this 2 tells us it's a vertical stretch by 2. And then we want to talk about what about this 5 right here. So remember, this is opposite because the equation, and we're comparing this to f of x equals the square root of x, right? So remember, we said it underneath that radical if it's opposite, okay? So this is going to be a horizontal, right, movement. So what does that mean? It's going to move right 5, okay? H horizontal, okay? So now what I want to do is I want to create a table here so that I can put some values in here and graph them. So when I look at this equation, I know that I can't have a negative number underneath that radical. So I'm going to start with 5 here. And then I'm just going to step it up a little bit. I'm going to put 7 in here. And then when I'm looking at that, if I do 9 minus 5, I get 4, right? And I can take the square root of 4. So I'm going to do that. Now, I could also do 6 in there because 6 minus 1 is, we could do that as well. So let's go ahead and do that 6 as well, and then we'll do 9, okay? So when we do 5, 5 minus 5 is 0, and 0 times 2 is 0, right? And then when we do 6, 6 minus 5 is 1, 1 times 2 is 2. When we do 7, we would do 7 minus 5, take the square root of 2, and multiply that times 2, and I got 2.83 when I did that. And then I'm going to do 9, and when I do 9 minus 5, that's 4. The square root of 4 is 2, and 2 times 2 is 4, okay? I want to pause right here and show you guys how you can do this on the calculator. Okay, so if you guys have a graphing calculator, what we're going to do is put this equation, we're going to go, let me just come out of here so you guys can see where I'm going to go. I'm going to click y is equal to here, and then I'm going to put this equation 2, and then I'm going to put the square root of x minus 5. So now I could click graph here and we could see the graph of it, which might help me a little bit to determine exactly where do I need to go here. But what I want to do is I want to use my table function. So I'm going to go second graph here, which allows me to see a table, okay? So notice here when these numbers are in here, we've got errors, errors, errors. And the reason there's errors there is because we can't have a negative number or a number less than 5 up there. So what I want to do right now is I want to go in and I want to change my table. So I'm going to go second table set. What I want to do is I want to be able to put some values in here for my x's. So I'm going to go down here and I'm going to actually change this to ask. And I'm going to push enter. Okay, so now it's going to let me, when I go to the table function, put in the values I want. So if you recall the numbers that we talked about, we put in 5. So we're going to put in 5, and that was 0, and we put in 6, that was 2, and then I think we put in 7, and you can put in whatever values you want, guys, and then plot them, and then we put in 9. So notice what this is doing for me. This is computing those values for me. So it's a great check to see if you got the right values, but it's also a good way to compute the values that you need there. So we got the same values we got here. So we're going to go ahead and plot those now. So we're at 5, 0. So that's right there. And then 6, 2, which is right there. And then 7, which is 2.83. So it's about there. And then 9, 4, right? So that one's right there. So then we're going to go ahead and draw our graph of that, okay? So now, remember, we talked about our domain. Now, this graph is going up and to the right. So we said our x is going to be, in this case, greater than or equal to whatever our h was. So what was our h here? It was 5, right? Okay. And then our range is going to be our y excuse me, and we didn't have a k on this one, so that means y is going to be greater than or equal to 0, okay? So now we're going to move on to the cube root, and again, this is the value. We're looking at f of x is equal to the cube root of x. So we're talking about how does this change, right? So we want to talk about the description first. So notice that there's a negative out front. So that means we're going to have a reflection over the x-axis. And then we have nothing underneath the radical that's changing. So we have no h, but we do have a k. So what happens to this k? This means we are moving what? Down 7, right? Okay, so now we're going to talk about, again, we're going to create a table here. And we're just going to put in some values. And I'm going to put in some values that I know I can take cube roots of. So I'm going to put in -8 because I know that that's a perfect cube, and -1, and then 0, and 1, and 8, okay? And I could pull these from our original graph, right? Because that's what we did when we did cube roots. So what I'm going to do, again, now I can put this in my calculator, and I'm going to show you guys how to do that again right here now. So again, I'm going to go to y is equal to, and don't put a minus here, but put a negative. You're going to put this right here, negative. And then I'm going to put this in parentheses. I'm going to take it to the cube root, which means I'm going to take it to the 1/3 power. So I'm going to put parentheses, and then to the 1/3 power. I'm going to put that in parentheses as well. 1 divided by 3. And then I'm going to go down, and I'm going to subtract the 7 from that. So now I can do -7. All right, so I'm going to graph it first, just because I want to see what it looks like. And you should notice that this is flipped from what it was originally, right? Okay. And now I'm going to go to second, and I'm going to go to the table function. And I'm going to put in the values that we talked about. I'm going to put in -8. I'm actually going to, I'm just going to go -8, enter, and then I'm going to go -1, and then 0, and 1, and 8. So notice what we got. So now I would take these values and I would put them in my table, and then I would use those to graph, okay? So now I'm putting those values that I got in here. And again, you guys can do this manually, but you can also use your calculators to do it. So now we're going to go ahead and plot those points. So we've got -8, -5. So -8, -5 is about there. And -1, -6 is about there. And then we've got 0, -7. And then 1, -8. And then 8, -9. So here's our graph this time. Whoops. Yep. It's kind of hard, y'all, with this pen. It's not perfect. So, all right. So again, remember, we talked about domain and range for cube roots are all real numbers, okay? So there we go.